Hey guys, today let's solve the surrounded regions problem. Okay, so this is the given problem, right? Region at here are represented by O, and the surrounded region here, that means the O or region need to be enclosed by the edge vertically and horizontally, like this, three of these, right? Then what we need to do is to capture the region on the given board by flipping them into S. However, the border region doesn't need to be flipped or doesn't need to be captured. So how we can solve it? So to solve this problem, actually we can use matrix DFS, either its iteration or recursion style, or matrix BFS. Then first, what we need to do is we explore the border regions or border matrix. Then for every regions that we encounter, we do DFS or BFS to mark them as T. Then after that, what we need to do is we explore the inner matrix and capture the surrounded regions by flipping the regions to X, right? Then the third step is for every T inside the matrix, we need to release them by flip back to O. Okay, that's all. Let's take a look at this example, right? This one. The rows is, how many rows at here? The rows we have is 3 rows. Meanwhile for the column, we have 4, right? Then the first step is we explore the border regions, right? We need to explore the first row. Is there any region on the first row? Yes, right? That is on board row 1 and column 1, right? So we do the DFS row index 0 and column index 0, right? Let me do this. Then this will need a space. Okay. After that, inside the DFS, we mark the board as temporary. Mark as temporary to avoid being flipped. Then we explore the 4 direction, right? That is 0 plus 1, 0. This is down. DFS 0 minus 1, 0. This is up. DFS 0, 0 plus 1. This is right. DFS 0, 0 minus 1. This is left. Okay. On the right side, is there any region? No, right? No region. How about on this? This is out of bound. How about on the, on the downside, no region. On the right side, also no region, right? On the left side, this is out of bound. Okay, then we continue, right? There is no other region on the first row, so we continue to last row. Is there any region on the last row? No, right? There is no region at all. So no region at all. Continue, right? Then we need to check the first column and last column, right? The board after being flipped. It will be like this. On the first column and last column, there is also no region at all, right? So we will just continue, right? Then we continue to explore the inner matrix, right? Explore the inner matrix. Okay. On the board 0, index 0, is it a region? False, right? It will continue. This one is 1. False. Two, 3. False, false, false. Okay, on the first row is done. Then we explore again. This one is 1, 1, 1, 1. On the 1, this one is true, right? This one is also true. So what are we gonna do at here? We flip them, right, into S. Capture the surrounded regions. This also we need to capture them, right? Capture the surrounded regions. After this, the board will be looks like, hold on. This. Then we need to continue to check on the last row, right? There is no region at all, and the last step that we need to do is, for every T, we need to flip them back, right? So this will be look like this. Okay, let's turn them into a code, right? Const surrounded region. The input is board. First we need this one is option 1 matrix DFS with recursion style. Console is board.length. Const cost is board index 0.length. Then we need to explore the border region, right? For let C is 0, C is smaller than cost, C plus plus. So we check the first row if board first row and C is a region. We do DFS first row, then the column. This one is first row. Then if board last row is rows minus 1, then column, if it's a region, we do DFS rows minus 1 C last row. Then we continue again to explore the border region, right? This one is rows, then L plus plus. If board L, then first column is a region, we need to do DFS L and 0. This is first column. Then on here, if board L cost minus 1 is region, we need to do DFS L cost minus 1 first column. Then we explore the inner matrix, right? We need to look through the rows and column. So for let L is 0, L is smaller than those, L plus plus. For let C is 0, C is smaller than the column, C plus plus. Then capture the surrounded region, right? If board L C is a region, we need to flip them, right? Both to S. Then else if both LC is temporary, we need to release them by flip them back as region. Okay, then we need to do the DFS, right? Not as temporary, cause DFS row column dot row call as temporary, then explore for direction DFS row plus 1, then the call this one is done. DFS row minus 1 and column this is up. DFS row call plus 1, this one is right. Row column minus 1, this one is left. Then another thing is that we need to create the base case to check if of bounds or not on regions. So if row is smaller than 0 or call is smaller than 0 or row is bigger or equal to rows or call bigger or equal to calls, or both row and column is not a region. We just need to return. Okay, before this we already do the guideline, right, at here. So I think like we can continue to do the time and space complexity analysis. Let's do this. This one will be OM time, where M is the length of the row. And for this it will be OM time, where N is the length of the column, right? So this will be O M multiplied by N time. This will be OM time. This will be ON time. And meanwhile for the DFS, the worst case scenario is we need to visit each cell once, right? So this also will be OM multiplied by N time. How about the space? Due to the recursion using stack, right? It will also be OM multiplied by N space due to recursion using stack. So this will be OM multiplied by N time and OM multiplied by N space. Okay, I think like we can continue to option 2, matrix BFS. Let's surrounded region. This will be both rows is both dot length. Call is the column will be the index 1, index 0, the length. Okay, then let's explore the border region, right? For let C is 0, C is smaller than cos, C plus plus, then if first row is having any region, we need to do the BFS. Then this one is last row, right? we need to do BFS rows minus 1, then column. Okay, this one is first row, this one is last row. Then we need to check the first and last column as well, right? So I'll just copy this. B. Okay, then for this I will also copy this because they are exactly the same. The only difference is on the BFS function. Let's see. BFS row call. What we need to do is mark them as visited, that is our work row. Call as temporary, right? Not as temporary. Then we create a new queue. I want to use the queue class. Then this should be queue dot push row and column. Then what are they doing is, if the queue is not empty, const current row and current call queue dot queue. The queue class use shift. Okay, then we'll submit the direction, right? Const directions -1 0, this is down, -1 0, this is up, 0 1, this is right, 0 minus 1, this is left. Then we need to look through the, oh sorry, this is not if, it should be while loop. For const direction row and direction column of direction, const new row is current row plus the direction row, const new column is current column plus direction column. Then we're gonna check if explore for direction. If the row is bigger or equal to 0 and the call is bigger or equal to 0 and the row is smaller or equal to rows, no, they need to be smaller, and the call is smaller than calls, and both row call is a region. What do we need to do? We're gonna mark them. Oh, this one need to be new row and new call, right? We mark as temporary, new row, new call, st, then queue the push, new row, new call. Okay, I think like that's all. Hold on, I think it's supposed to be new row and new column. The new row supposed to be smaller than the total rows, right? The new column as well, to be valid both. Okay, this one we also can use array, by the way. You can just do like this. Yes, then this one you'll just need to while q.length is bigger than 0, then you will just do this. And because q are first in first out, right, you need to use first in first out shift, because q is v4. This should be comma. I think like this. Let's do the time and space complexity analysis, right? This one is already done. This one is also done. This one will be on time. Because we explore the 4 direction, right? And we are using q. This will be om multiplied by n space for the worst case scenario. This will also be om multiplied by n time. So matrix BFS is om multiplied by n om multiplied by n space. I think like that's all. Let's take a look, right? First, we need to do the console is put the length. Cons call is but in the 0 the length. Explore the border region. Can we just copy it? Let's see, right? Let's see. I think yes. Let's copy this too. I just missed it. I will just type it. Okay. So for this, I will just delete this first. If the board is a region, we need to capture them, right? Capture the surrounded region. Else if board C is T or temporary, we need to release the border region, right? Okay. I think I just need to type it again. BFS, this one is the row, call. Then after that we need to mark as visited, right? Board row and call. This one is marked as temporary to avoid being flipped. Okay, marked as temporary. Okay, then cons q is array, q the push, row call, while the q the length is bigger than 0. Cons current row and current call is q is first in first out, so shift. It will need to explore the direction, right? We need to type it again. Cons direction 1 0, this is down. Minus 1 0, this is up. 0 1, this is right. 0 minus 1 is left. Okay, then what we need to do is we loop them of direction, then cons new row, that is the current row, we plus the direction row, right? Cons new call is current call plus DC. Okay, if the row is bigger or equal to, it should be new row 0, and new call is bigger or equal to 0, and new row is smaller than the rows, and new call is smaller than calls, and insert new row, new call is they needed to be a region. What we need to do? Well, of course, we need to mark them as temporary first, then q.push. This one should be new row, new call, q.push, new row, new call. Okay. I think like that's all. Then this one is explore the for direction, right? Then this one OM multiply by n space for the worst case scenario. OM multiply by n time n. OM multiply by n space. So overall for this, option 2 matrix BFS is OM multiplied by n time n, OM multiplied by n space. Let's see. Hold on. Invalid or unexpected token at here, line 46. I think on off because I copy past them, right? It's on here, and this as well. It's always happen. What we need to do just like this. Okay, I think it's all looks good. Is it all okay now? I guess so. No, there is another one. Okay. Okay, let's submit. It's a BFS. Oh my god. Okay, submit it again. Okay, I think that is all. See you next time.